So guys, now let us discuss the steps involved in designing a thread pool functionality. So you can see that we have an application A, and this application wishes to harness the benefits of the thread pool. So what does this application does is that as soon as the application initializes, it creates some n number of threads and places all those n threads in a thread pool, right? So this is how the thread pool takes a birth. Now let us suppose that in future the application needs to do some amount of work W, right? This work W could have been created as a result of receiving some network packet from outside, or maybe the application has received some input from the user. As a result of which the application reacts and the application wants to do some amount of work W, right? This is the step number one. Now the application wants to perform the step W in the context of a separate thread. So for that, the application fetches the thread from the thread pool. So let us suppose that in step number 2, the application fetches the thread T1 from the thread pool. Now a thread T1 can be executed only when we know the thread function and the argument to be passed to that thread function, right? Every thread executes some function called thread function. We already know that. So this work W is nothing but it is function plus argument, right? And we allocate this function and argument to the thread T1, which we have fetched from the thread pool. So in step number 3, we associate a thread, which is an execution unit, with the work to be performed. And work is nothing but it is a thread function plus argument, right? So once the step number 3 is accomplished, the thread T1 is made to execute. That is, thread T1 now execute its execution flow. And after completing its allocated amount of work, the thread T1 finally finishes its work in step number 5, right? Now once the thread T1 finishes its assigned work in step number 5, the thread T1 places itself back to the thread pool. So in step number 6, you can see that the thread T1 parked itself back to the thread pool because it has completed whatever work was assigned to it. And optionally in step number 7, the thread T1 can send the feedback to the application telling the application that I am done. So step number 7 is optional. We will see how to implement this optional case. So you can see that in this complete cycle, step number 1, 2, and 3 is performed by the application itself, right? It is the application which generates the amount of work. It is the application which fetches a thread from the thread pool. And it is the application which associates the thread with the work, right? So step number 1, 2, 3 is performed by the application, whereas step number 4, 5, 6, 7 is performed by the worker thread itself. Worker thread means the thread T1 or the thread which has been fetched from the thread pool, right? So going forward, we will going to implement these steps from 1 to 7 in stages, right? Step number 1, 2, and 3 is categorized as stage 1. Whereas step 4 and 5 is categorized as stage 2. And the step 6 and 7 is categorized as stage 3. So we have divided these steps in stages. The reason is that we will going to implement each stage as a separate function, right? Corresponding to stage 1, we have a function f1. Corresponding to stage 2, let's say, we have a function f2. And corresponding to stage 3, we will have a function f3, right? So this explains the high level design regarding how thread pool needs to be implemented. This also explains the interaction between the application and the thread pool. And this also explains that what part of the work has to be implemented by the application and what part of the logic has to be implemented. So now in the next lecture video, I will going to discuss what are the APIs and data structures we need to design in order to implement the thread pool functionality to our thread library.